This is chapter 8.3, exercise 1 through 10. Section 8.3 in our book has to do with hyperbolas. And this video lesson is going to cover these odd numbers in the set 1 through 10, 1, 3, 5, 7, and 9. In exercise 1 through 6, find the vertices and the foci of the hyperbola. The equations for hyperbola are similar to those for an ellipse, but with some key differences. I'm going to write some standard forms of the equations here to begin. There are two different forms of hyperbolas, and one we're going to get by taking quantity x minus h squared over a squared, and instead of having a plus sign like for an ellipse, we're going to have a minus sign. So we're going to have minus y, quantity y minus k squared over b squared, and those will be equal to 1. And there's another form of the equation that's very similar to this, but will be for a differently oriented hyperbola, and that would be quantity y minus k squared over a squared minus quantity x minus h squared over b squared equals 1. And so what we have is A equals our semi-transverse axis. And in line with the transverse axis, that's kind of analogous to the major axis for an ellipse, but you can see how that is different. And then our B is going to be, we call that the semi-conjugate axis. And similarly, for the second form of the equation, the A underneath the y term is going to be the semi-transverse axis, and the B is the semi-major conjugate axis. So let's go ahead and take a look at how this works. Find the vertices. Oh, for the foci, it's really the Pythagorean theorem. We have c squared equals a squared plus b squared. So let's go ahead and look at this. Now, for this one here, we don't have anything with the x. We don't have a minus h or a minus k for the y. And what that means for us is that we have a hyperbola that is centered at the origin. So in this case, our semi-major axis squared, or semi-transverse axis squared rather, is equal to 16. So our semi-transverse axis is going to be the square root of 16, or 4. And so this is going to be key to where our vertices are. Now, what's going to happen here is if b squared equals 7, b, or our semi-conjugate axis, is going to be square root of 7. And so now we can graph, and to do that, Let's draw XY axis here. and our semi-transverse axis is 4, and so what we do is we go 4 units to either side, -1, -2, -3, -4, +1, +2, +3, +4. So our vertices are located, and I'm just going to write them, vertices they're at the points 4, 0 and -4, 0. And sometimes you'll see them written together. So now for the foci, we have to find the foci. Well, the equation is the same as Pythagorean theorem. We have c squared, and c is going to be our focus, our foci, equals a squared. Well, a squared is going to be 16, and then plus b squared, and b squared is 7, so we have 23. So c squared is equal to 23, and so c is going to be equal to plus or minus square root of 23. And usually in distances we just deal with the plus, but we'll be able to sketch where these foci are. And as opposed to an ellipse where your foci are going to be between the vertices, in a hyperbola, it's almost like a turned inside out ellipse. And so square root of 23 is going to be a little less than the square root of 25. The square root of 25 is 5. So we're just a little bit less than 5 on either side. And so here, this little dot I'm drawing is right here on either side. And as far as the coordinates of the foci, and foci being plural for focus, are going to be square root of 23, 0, and also negative square root of 23, 0. So here they are. And in parting, I'm just going to sketch the hyperbola. Not that it calls for that exactly, but here's what it's going to look like when I use the purple. You're going to be coming from this direction here. Okay, something like this. That's more gradual than that, but it will come like this. So this is what our hyperbola is going to look like. And not a very great sketch, but enough to see the basics with the foci and the vertices. The next odd number problem we're going to look at is 3. And 3 is going to take a slightly different version, in that our a squared is going to be 36. So therefore a, which is our semi-major, or I should say semi-transverse axis, is going to be the square root of that, or 6. And we have y squared over 36, meaning that we're going to have a differently oriented hyperbola. And then for the 13, we have b squared is equal to 13, and therefore b, or semi-conjugate axis, is equal to square root of 13. And then to take care of our foci, we have c squared is equal to a squared plus b squared. And so we have c squared is equal to a squared is 36, and b squared is 13, and 36 plus 13 is 49. Therefore, c is going to be our square root of 49, which is going to be 7, which you can put it as plus or minus 7, but in any case it can be 7 units from the origin. And yes, at the origin, because we don't have y minus something or y plus something, nor do we have x minus something or x plus something, so we can just sketch like this an xy coordinate plane. And we know our a value is 6, so we're going to go 6 units up from the origin, 2, 3, 4, 5, 6, and down 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And then our vertices are right here at 0, 6 and 0, negative 6. So I'll just write them down here. Vertices okay, 0, 6, and also 0, negative 6. Now for the foci, we have c is equal to 7, so we're talking about 7 units either direction from the origin. So we're going up one more unit above 6 to 7, and one more unit down below negative 6 to be negative 7. And so I'm going to mark our foci right here, just on either side of the vertices. So for our foci, we have the points 0, 7, and also 0, negative 7. And we can, as we did earlier for problem 1, sketch. So we're going to have a hyperbola that looks something like this. And they look almost like a parabola. It just was not very good looking. It's like I'm getting glitchy. Okay, now. Okay, that's a little better looking. And this one here is going to be like this. Okay, that's about as good as I can do. There's also something called a slant asymptote that we're going to get into later exercises. But basically, that's it. So here are our answers right here. Next, on number problem 5, this one we have a level of complexity in that we do not have standard form. In standard form, we need an equals 1 to the right side. And so what we're going to do is arrange for that to occur by dividing both sides of this equation, which means all terms, by 12. And what happens when you divide 3 by 12? You get 1/4. So what that translates to is x squared over 4 minus, now 4 over 12 is 1/3, so we're going to get y squared over 3, and 12 over 12 equals 1. And so in this case, a squared, which is our semi-transverse axis, is 4, and so our semi-transverse axis itself is going to be the square root of 4, which is 2. And for our semi-b, or our semi-conjugate axis squared, is going to be equal to 3, and therefore our semi-conjugate axis is going to be equal to the square root of 3. And all we have to do is find the foci. Well, to do that, we have, well, we can just write the vertices, we have 2, 0, comma, -2, 0. And we know these are going to be along the x-axis since the x squared term is the first one before subtracting. And now for the foci, we have the equation as we had earlier, c squared equals a squared plus b squared. So c squared is equal to a squared, which is 4, plus c squared, b squared, which is 3. So c squared is equal to 7, and therefore c is equal to the square root of 7. And for our foci, our foci are going to be located at the points square root of 7, comma 0, and also negative square root of 7, comma 0. And we can just write, we can arrange this. Let's make this drawing up here. Okay, we have an XY coordinate plane. So there we have it. XY, and that's X, that's Y. And our foci are located, well, let's look at the vertices first. Plus or minus 2, so there's plus 2, there's minus 2. And so here in red, this red dot at the right, that's one of them. And the one at the left of the y-axis is the other of the vertices. And then for foci, we have square root of 7. Well, square root of 7 is between square root of 9 and square root of 4. So it's going to be 2 point something, close to 3 kind of. So it's going to be just on the outside of the vertices. And then just a sketch, we'll have something like this. Okay. Yeah, that's more or less right. Okay. That's about as well as we can do it. So here we have our answers. We box in. That's correct. And from here we'll go on to the last set. And this last set we're going to look at is an exercise 7 through 10, match the graph with its equation. So we just have to analyze what's happening here, and it should be pretty easy by process of elimination. We'll just start at 7. Now we don't have x plus or minus anything, nor do we have y plus or minus anything. So we're talking about a centered, at the origin type of hyperbola. And also we have a is underneath our x squared is the first term. So we're talking about a left-right type hyperbola. And the only one that it really could possibly be is c. And let's just kind of double check that. Now, if we have our semi-transverse axis as the square root of 25 or 5, we're going to be 5 on either side of this y-axis. So we go 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5 to the left. So that looks like checks out pretty well. Okay, next, 8. We have y squared over 4 minus x squared over 9 equals 1. So this is going to be a different type. It's going to be a vertically along the y-axis type oriented hyperbola. And it's also going to be centered at 0, 0 because we don't have y plus or minus anything for k, nor do we have x plus or minus anything for h. And so the only possibility would be this choice B. Okay, let's verify that. We have our semi-major, our semi-trans, I want to say semi-major, but it's really semi-transverse axis is going to be the square root of 4, or 2. So we should be 2 above the origin, which we see here on choice B, and 2 below the origin. So that confirms B is our correct answer. Next we have 9. We have 20y minus 2 squared. And also, this one we're going to have a vertically oriented hyperbola as well. Well, minus 2 is going to move. That'll be like 20y minus k squared. We're going to move up 2. So on A, you're moving up 2. And then with x plus 3, we're going to move to the left 3 units to get the order. So 1, 2, 3. So right here in the center. So that one checks out. That's going to be answer choice A. And the last one we'll be able to get by elimination has to be D, but let's just check that out for sure. We're going to have a major, first of all, we have a dislocation. We have x minus 2, and so that's going to shift our center 2 units to the right, okay, where I'm drawing this now. And also y plus 1, that's going to shift down 1. So right here where I'm marking in red is going to be what the center should be. And we are, since we have our semi-transverse axis, it's going to be a square root of 9 or 3. We're going to be 3 on either side, so that checks out. So these are all the odd-numbered problems with the addition of 8 and 10 as well. It just worked out better for this exercise. Well, good luck on the rest of your problems. And as always, thanks for viewing.